All right, folks, and thank you for tuning into the YouTube live stream exclusive here. Streaming live to YouTube for today's daily space weather video. And we'll be live at the moment of the equinox. So that's part of the point. We'll be doing a slightly extended edition today, and obviously we won't be tuning into any live premieres because I'm at the premiere. Here I am. So if you've got chats, leave them on the screen, and we'll put those on the screen at a later time. We've got a coronal mass ejection going on and geomagnetic storm conditions striking all at the same time. So lots of stuff to cover. Here's the coronal mass ejection from the perspective of stereo A. So that's the location of stereo A there, Lagrange point 5. And there's the propagation of the initial portion of the coronal mass ejection, which could actually still be occurring now. Sometimes these things take over a day to fully unfold. And this one here, I guess I'll leave you in suspense. Is it Earth facing? You may be wondering. Now we'll let you know in a moment here. First, a 171 angstroms full disk image here on the SDO browse data section. If you want to bring this up yourself, it's under data, AIA/HMI browse data. So here's the view from the LASCO C3, and you can see Venus there on the imagery. And you'll see the coronal mass ejection appearing to only come out of the eastern limb. So we would expect that to be an Earth misser. You see this area right here. We don't see any propagation of this out of the north, south, or western portion on the C3 coronagraph. Here's the C2 coronagraph. It'll give you a little higher res, as well as an even closer up view of Venus. And by the way, the reason Venus looks so bright on this is because of the contrast. The contrast has to be set in such a way on this imagery to show the corona. And planets are way brighter than the corona. That's why the planets appear so bright on the LASCO and stereo imagery. So a view of that. And then back to the sun here, 171 angstroms. We've got another active region rising. Not there, actually here. And it looks pretty hot, actually. It looks quite active. So I think that is going to be a sunspot. If I had to bet, if I was a betting man, I would have to bet that that was a sunspot. And perhaps we'll talk about betting in a bit, but first let's talk about orientation. And if you're wondering where stereo A is located, it's someplace around there. Stereo B is located someplace around here. And actually Venus is passing in front of Lagrangian point 3, where that third purple dot is there. Lagrange point 3, folks. And then here's Lagrange 1 and Lagrange 2 are located around there. And anyway, this is where stereo A is located. And this is where stereo B is located. So stereo A is looking in this direction, which makes the Earth off to your right. And of course, I'll go back to that for a quick moment. Here's the stereo A imagery. And in most cases, we have the best idea of the direction of a coronal mass ejection with stereo A. Now, we used to have stereo B also. It's taken some damage. I think it was in September of 2015, if I remember correctly. It suffered, quote, a hardware anomaly. So, in any case, welcome to the last 35 minutes of winter. And again, if you've got comments, leave them for us. Whether you're viewing live or you're viewing Memorex, we do read all comments. So there's the countdown to spring. Enjoy your last half an hour of this dark, dark winter. Oh, no, it's such a scary, spooky, dark winter. I would also note for you viewers out there, we put this new graphic up here. It's a GIF animation of approximately what goes on around the galactic core. And we just wanted to put that up as a little reference here. And this is projecting to the year like 2100 or something. But what you're looking at there is stars orbiting a galactic core. Whether that's a simulation of the Milky Way galaxy or not, that's what that is. I think that is the core of the Milky Way, though. So you've got, S1, S2, S3, and so on. You've also got this long, extremely elliptical orbit here. And the point is, folks, the galaxy is nothing like the solar system. I'll just leave it there. The galaxy is nothing like the solar system. And the Earth's equator is about to cross the sun's in only a little over a half an hour. We'll get back to that momentarily. And the equinox occurs at 5:37 and 31 seconds a.m. Eastern Standard Time. So for everybody on the East time zone of the U.S., 5:37 and 31 seconds is your equinox. And we figured we'd stream a little bit early just for that reason, to be well ahead of the equinox. Here's a star chart. And I ask you, where will you be when Cygnus sets? Right? Are you familiar with Alpha Cygni? We'll talk about that later. By the way, if you're up before dawn, you may see a planetary pileup. You've got Saturn and Jupiter and Mercury and Venus all rising ahead of the sun. Barely ahead of the sun. As Venus is just about to head around to the backside. Anyway, I like to draw in the ecliptic. That's what this yellow line is. And my sky chart's facing to the south if you want to build one yourself. in-the-sky.org is what I use. And so the sun's been emitting photons, radio frequency photons, and the 10.7 centimeter variety, or 2800 megahertz if you prefer, is still only at 74. So lots of activity here despite pretty weak radio output and sunspot numbers. And there are those two things in context for you. It's a one-year chart showing the radio flux of this top black line and the sunspot number, the bottom red line. And you can see how proportional those are. By the way, the Geomagnetic Forecast has been updated here. It's not even on Space Weather Enthusiast dashboard yet. I'm just letting you know ahead of time because I'm aware of this. We're already in a KP of 6, folks. So we already see geomagnetic storm conditions upon us. We'll be changing the title and the thumbnail later to make this look like the rest of the daily space weather videos. And thanks to everybody who tuned in live. Thanks for leaving comments. Be stoic. So all kinds of exciting stuff happening all at the same time here. And it's either luck, divine providence, a combination of both, or neither. Are you familiar with Fagradalsfjall? Have you learned how to say Fagradalsfjall yet? Well, you might as well because it's erupting. So this image here, that's the sky over Reykjavik. Check it out. The sky over Reykjavik was glowing red as the Fagradalsfjall volcano burst to life. We've actually got 2 Icelandic volcanoes on the list today. I would remind our viewers not to pole vault the caldera. And we're not kidding. Don't pole vault the caldera. I'm not screwing around. If you pole vault the caldera, we're gonna have issues. I will revoke your skate shoes if you pole vault the caldera. Do not pole vault the caldera. I will start thinking about things, and it will look like this, and then I'll get very angry. No pole vaulting of the caldera, please. Here at the Smash News Network, we try not to tell people to do idiotic things. Please don't do idiotic things. It's true, folks. It's 2021. You have to tell people this stuff. So yeah, crazy stuff going on. Fagradalsfjall is now erupting. If you haven't learned how to say it, you might as well say it now. Some great imagery of that. I think we've got a video as well. That article from The Sun. Oh my God, I've put a story I didn't mean to put on the screen. By the way, if you haven't checked out our COVID Chronicles series, we made the first video in that last night. So there you go, Fagradalsfjall erupting, some lava fountaining, and a new caldera opened, a new fissure opened, reaching 500 to 700 meters in length. Don't pole vault the fissure or the caldera. Don't pole vault the fissure, land in lava, and then blame me for melting off your foot. Don't melt off your foot. All right, so here's a video by, I think it's a Twitter account, the Twitter account of the volcanic folks in Iceland. Great view of that. It looks like pretty non-viscous. It's pretty runny lava, folks. And this will not go full screen, or I would full screen it for you. But you can find that on volcanodiscovery.com. From the Coast Guard helicopter. Don't fly your helicopter over the caldera either. So here we go, the second volcano here also, Krýsuvík in southwestern Iceland. Now exploding and producing a 20,000-foot ash plume. So big uptick in Icelandic volcano eruptions. Kind of saw this one coming, as it was noted several times. Abiko, flight level 10,000 over that. Sakurajima, 9,000-foot plume of ash above it. At least the top of the ash plume around 9,000 feet of altitude. Cinnabung, flight level 100. It's a 10,000-foot altitude ash plume. Dacono exploding, flight level 070. San Cristobal, significant volcanic ash eruption. That's in Nicaragua, by the way. Nevado del Ruiz in Colombia now back on the list. Sangay also exploding. Those two 21,000 and 20,000 foot ash plumes respectively. Please don't fly your drone or hang glider over that. Revenador also exploding in Ecuador. 15,500 foot ash plume over that, and unable to detect Sabancaya. Please do not pole vault the caldera. Today's featured product is the Google Bias shirt. Now, Google admits that it's biased, which is why it'll sell you higher positions and create a bidding war for where products that you're interested in advertising will appear on the search page. So that is an inherent bias. Now, the way Google became the world's leading search engine was by having simple algorithms. And what do you think of Google's algorithms now? You think they're simple? In any case, you can find that link. You can find the link to our Redbubble shop at smashomash.com. It's under smAsho merch. So that little link right there will take you to our Redbubble shop. You can also find our social media and so on our homepage, as well as the first videos in the smashomash.org Presents the Sun series. We've got, I think, 1 through 9 on the homepage. So perhaps check those out if you haven't seen the smashomash.org Presents the Sun series. Check it out. Maybe check out number 3. It's got Beethoven's Moonlight Sonata as the accompaniment. And there's the Redbubble shop. You may find some other interesting, edgy products there that you like. And I would remind you again not to pole vault the caldera. Largest earthquake of the past 24 was a 6.1, very far south, near the Antarctic and South Indian Ocean plate boundary, I think it is. There's a location of that. And you get off my screen now, you. That happened at 5:19 Universal Time. Only a few hours before spring. Which, by the way, is only 25 minutes away. All right, let me get back to this. So largest earthquake of the past 24 was a 6.1. Here's an extremely shallow quake at Hawaii. And we've been noting this for a long time, these shallow quakes under Mauna Loa. This is another one under the eastern flank, and we've reported on this the past 2 days as well. The officials assure us that that's not based on magmatic activity. What do you think? Leave us a comment. Leave us a comment. It's just the ground settling, folks. Here's a 4.8 at Papua New Guinea. By the way, Mauna Loa is the world's largest volcano. Saw a deep quake at Papua New Guinea. There it is, a 4.8. It happened at 1646 yesterday. Also more quakes there north-northeast of New Zealand in the Kermadec Trench and the Tongan Trench. And this 5.6 was just in that spot at the very southern tip of the Kermadec Trench. This is the Kermadec Trench. And this is the Tongan Trench. Why that's not just one trench is because 2 different people probably discovered it. But in any case, that's where that quake was, not far from the site of the 8.1 we saw several days ago. Small deep quake in the Caribbean. And once again, Peter Schiff, leave us a comment and promote the channel on your podcast. Peter Schiff, everybody. A guy who I do not know and does not know me, but does know economics and is a breath of fresh air. The Peter Schiff podcast, folks, highly recommended. 4.0 at the Virgin Islands, another deep quake there in the Caribbean. So a couple small deep quakes in the Caribbean, not uncommon. Not sure it's relevant to anything at all. 4.3 in the Marinara Islands. Oops, not the Marinara Islands. There are no spaghetti sauce islands, folks. It's the Mariana Islands. That's what it's called. Yes, that's what it's called. Small deep quake there. Oh, we saw a 5.7 in Mexico. Not every day you see that. Right on the coast there. And again, here's this 6.1, which occurred there between the South Indian plate boundary and the north portion of the Antarctican continent. And I just zoomed in roughly, and it made no sense right on the plate boundary there. And I do not like this map. I don't know. No, not to cast shade on the USGS. I just don't like that map. It's something about the software. It's icky. I find it to be icky. All right. Continuing on with some more solar data here. No solar flares. So once again, another prime example of seeing 0 solar flares and seeing coronal mass ejections. We've covered it repeatedly on the channel, and we've been forecasting and putting various different alert levels. I think we have to make a color system. We're going to have to make a color system for coronal mass ejection warnings. And sorry, I can't explain how the coronal mass ejections are forecasted. They just are. And I could explain how, I'm just not going to, for a series of reasons that I also will not explain. The GOES proton flux is not showing any spikes, and we're not expecting any, because that coronal mass ejection is expected to miss Earth and not even really get near the geospace. The GOES magnetometer is showing some big spikes here, and no surprise, as the coronal hole wind stream has just arrived, we saw solar wind densities all the way up to over 60 protons per cubic centimeter at about 12 times what they were yesterday. So no real surprise there, as there is a giant series of solar protons in between Earth and the Sun right now. A giant string of them. And here's what the heliospheric current sheet looks like. And we will be keeping you posted. We'll probably make another video later today about the possibility of additional coronal mass ejections or the resolution of the one that's not done unfolding yet. So anyway, back to this. This is, for you new viewers out there, this is stereo A and this is stereo B. And this data is derived from ground magnetometers on Earth, as well as magnetometers at Lagrange point 5 and Lagrange point 4. And this is pretty important data here, folks, as this shows us all kinds of stuff that we are completely unable to see. And so we show it daily on the channel, because really the forecasting of coronal mass ejections should not be a mystery if you understand the physics. So here's a line of sight coronal hole plot. This shows you the sun's B field in blue. So you see this blue series of potential field surface source lines. That's the sun's B field. And the sun's B field is essentially the extent to which the south solar polar field and the north solar polar field overlap each other. And the interaction between those two fields is what we call the B field. It's the one you live on. It's the interplanetary magnetic field. And it's being affected by this coronal hole, as well as some other stuff up here in the north, a couple active regions and a small sunspot group. But currently the main thing to look at is the incoming coronal hole wind stream. So we'll get to that momentarily here and talk a little more about that toward the end of the video, as well as show the coronal hole in some detail. Here's the filament situation, and the filaments that we saw turn into that coronal mass ejection are some of these down here. You do see those vanish at the end of the imagery there, and that is because they are now propagating through the solar system. And you can see sunspot 2810 is still alpha class. It's alpha class, and it's, I think, even smaller than it was yesterday. So here's the real-time solar wind, and we should see a ticking up here of the solar wind velocity, and indeed you do. And here's the peak. The peak of the solar wind density looks like it was around 62 protons per cubic centimeter. Let's bring up the 6-hour chart. And I don't think no, I think we do have the peak. All right, there's the peak. So 63.5 protons per cubic centimeter we got to. It's a pretty high density there, not unheard of. And that has sparked some auroras. So if you're in a place likely to see auroras, go out and look. If you've got clear skies, make sure you use your camera to take video or photographs, as some of the emission spectra are not visible to the human eye. So let's go back to the 1 day here. And we see the solar wind density having dropped off a bit here as the solar wind velocity came up. So the standard signature of a coronal hole wind stream is right there. You see this uptick in the density, followed by a downtick in the density and an uptick in the velocity. So that's the standard coronal hole wind stream signature, folks. Classic coronal hole. And again, we are already into G2 level geomagnetic storm conditions. So there you go. We're up to a KP of 6 here. So that arrived a little bit earlier. This was actually closer to the initial forecast, and then NOAA moved the forecast back. NOAA was expecting this to happen early tomorrow, and you'll see the changed forecast coming out. And you'll see the changed forecast coming out. If you're a patron, you may have already known about the KP6. And thanks to our patrons. Our patrons who do not stink. Does something stink? Well, get a breath of fresh air by viewing space weather on our channel. And seriously, though, thanks, patrons. The true source of funding for the content. And other YouTube viewers, feel free to thank our patrons as well. Please consider becoming a patron, as we need a lot more funding to do what we would like to do this year. Patreon.com/smAshomash. And patrons, if you'd like to leave a comment, let the other viewers know why it is you'd like to pay us a couple dollars per month. We've got tiers from $3 to $15 per month. And again, patrons, feel free to leave a comment and let other viewers know why you're a patron. And thanks everybody who got in on our ground level, as we've barely even started making content. So we're going to show all three geospace magnetosphere movies today. Here's the velocity. That's 4 hours of data, velocity data there on the magnetosphere, right at the beginning of the geomagnetic storm. Perfect timing. Was it luck? Was it divine providence? Was it a combination of the both? Leave us a comment. Let us know what you think. Shout out to the sun for providing activity at exactly perfect moments on the regs on our channel. In any case, there's 4 hours of density data as well. And you can see those high density regions. I'll let that play through again as it refreshed annoyingly right toward the end. You can see those areas of high density in dark blue, low density areas in white on this imagery. And you can see a small bow shock region of low density there. Possibly a second double layer being created. Here's the pressure data. And again, 4 hours of data here showing magnetohydrodynamic pressure in nanopascals. And not too surprising to see a high pressure environment there with the current incoming solar wind. So density again made it all the way up to 60. So here are ground magnetic perturbations, and we see major ones here. And these are actually, these red spots are pegged. So these are showing 400 nanotesla, but what the actual reading is who knows, because that only goes to 400 nanotesla. So there's that is a pegged graph right there. And this is, by the way, geospace delta B, which are changes in the Earth's B field, which is, of course, shaped a little differently than the sun's, but nonetheless, this is showing us the magnetohydrodynamic pressure on the Earth itself, the geomagnetics. And I'll actually let this play through a second time here, this polar view. Especially since it refreshed. So we'll just let that play through a second time. You can see the spiral-like nature, especially on the northern portion, but a similar shape starting to emerge on the north and south. And leave us a comment if you think the south geomagnetic pole is splitting as well. I'm still unsold on the theory, but there is some evidence of that, which we've been showing on the channel for a solid 2 years. Have you watched? Here's the geoelectric field. Now we're looking at induction into the Earth's power grid. as long runs of wires cause induced power. So the geoelectric field empirical data, this is, you're looking at, what are the units here? Millivolts per kilometer. So millivolts per kilometer as electricity is inducted into the electrical grid via the incoming solar protons. It's Bremsstrahlung showing up in your circuits. So here's the Aurora forecast as well, and you're going to see this suddenly kick up here as a result of the high-density solar wind followed by the high-speed solar wind. And once again, we'll let this play through as it has refreshed. You're going to see this suddenly kick up here about halfway through the video, I think. And if you're in a location where you're likely to see auroras, you're likely to see auroras. What the heck? There we go. Right at the end. So it looks like quite a lot of auroras there in Alaska, especially the north part, especially north central Alaska. The north shore of Alaska is actually, yeah, anyway. So there's kind of the current image. And in the south, sorry, New Zealand and Tasmania. Maybe Tasmania. Tasmania might be able to see some auroras there. New Zealand, a little less likely. And again, if you're in a location where you're likely to see auroras, make sure that you go outside and run a camera, run a digital camera, because as you may know, your cell phone camera can see the infrared light on a remote control. So that's just one of the many emission spectra that are visible through a camera that are not visible to the naked eye. So, by the way, we usually stream live to Twitch. Thanks to our Twitch viewers. We are not streaming live to Twitch today. We put up a video on Twitch to tell you to watch here. And again, thanks for leaving comments, YouTube viewers. By the way, we're also on Twitter. If you don't follow us there, we've got a whopping 128 followers on Twitter. One of my Facebook pages has about 5,000 friends, by the way, folks. And yeah, in any case, if you like the music that we played in the intro and that we'll play on the outro as well, it's Gem Cutter. The link is in the description. It's soundclick.com/goldencatproductions, our record label. We've been making music since about 2000. And we've got some representative tracks here on this page. Gem Cutter is the track we are playing. So soundclick.com/goldencatproductions. If you'd like some of the tracks, you can add those to your MP3 collection for approximately $1 a piece. And if you enjoy the content, press like and subscribe on YouTube. Press the notification bell, etc. As it's been interesting. Our subscriber count has been interesting. Let's just say that. Here at the Smash News Network, we are mortified by some of the antics at YouTube. And I do wonder how much Google AdSense actually pays out per year in revenue. Like total. What's the aggregate? You can probably find it in their financials. Have you seen Eugene's new video? He's got a new video called I Know Better. And I can really identify with this one because at the end he talks about shoving people into a box, as this is an issue that I've run into regularly. Because people can't shove me into a box because they have no idea what I think about anything, because they don't want to ask. They want to assume what I think about something because of what I think about something else, which makes them come up with a bunch of nonsense to argue with me. And I just go, you've moved the goalpost, which is why you're an idiot. So, and this happens all the time. This is This is one of the downfalls of Facebook, which measures its success by your engagement. Because if you're mad, you're more likely to comment than if you're agreeing with a post. But in any case, here's a little clip from Eugene's latest video, I Know Better. Shout out to Eugene.
Again, as I've stated in one of my previous videos, it's really not productive to address the people in the first place, right?
It's not productive to address people who have ridiculous straw man nonsensical arguments on social media and so on, so please don't. Anyway, check out the video. I think we shared it in a community post last night. Thanks to our BitChute viewers as well, bitchute.com/smAsho. There's exclusive content. In fact, one of our videos, the most popular video on BitChute, mysteriously premiered exactly a year ago yesterday. You know why? Because it got demonetized on YouTube. And so since it got demonetized on YouTube, whoops, it's no longer on YouTube. It has to do with a molecule. Anyway, if you only watch on YouTube, perhaps consider watching on BitChute. And if you only watch on BitChute, please watch on YouTube. Because YouTube has, I don't know, 60% more content than BitChute does. And let's do a cosmology segment. Today's cosmology segment is going to be a little different and a little the same. Here's the different part. See this graph? This graph is showing you various data points. It's showing you changes in the ratio between carbon-14 and carbon-12 in wood. This is a 1,000-year chart of solar activity based on said proxy data. Why are we showing you this? Because you see these solar cycles here? You see those solar cycles? That's 1,000 years of solar activity. So just keep this in mind when you're deciding whether to or whether to not believe nonsense that people say about the sun on YouTube. And I'll just leave that there. Just put a pin in that if you didn't understand it, folks. Next, I would direct you to smashomash.com/forum. There's a whole topic thread there in the Sun forum called Grand Solar Minimum. Grand Solar. Hey, that's a grand solar you got there. Be a shame if it minimum, huh? Let's look at cosmic rays as cosmic rays figure into climate. Here's the Apatity Neutron Monitor. And we saw this big uptick about 3 weeks ago. Since then, it's leveled off. But we see a significant uptick here over the past 30 days at Apatity. With respect to Barentsburg, we see no such pattern. So, totally different data set there at Barentsburg, although the most recent uptick is reflected in both. Next, we'll look at someplace much farther south than Barentsburg and Apatity. We'll look at Athens, Greece. And before I get greasy, I'm going to put your chats on the screen so that they're displayed during the video at some point. Otherwise, I may forget. By the way, we're only 2 minutes from spring, according to my clock. So we'll get there and we'll do a countdown in an undisclosed period of time. So again, thanks for leaving comments. B1, Be Stoic Primer, Nabo J, and Mary Wright. Oh my God, what did I do? Nothing. All right. Check it out. We're only 1 minute. What are you going to do with your last 50 seconds? I'm going to count down to spring. I'm stoked about it. And it's time to accelerate. If you've ever seen me step on the gas, you're about to. So, yeah, enjoy your last 36 seconds of this dark winter. Oh my God, the winter is so dark. The winter is so dark that I've got sunglasses inside. So only 23 more seconds until this dark winter ends. And thanks for tuning in, Waft 11. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and happy spring, folks. Happy spring. Cheers, you've survived another dark winter. Or perhaps a bright summer, if you're in the southern hemisphere. Who knows? Here at the Smash News Network, we're located in Lehigh Valley, Pennsylvania. And welcome to spring. What will you do? Will you put in fencing and attempt to grow things outside, edible things? Well, that's one of the things we'll be doing. And let's get back to the DSW. I think we were in Greece. Were you knee-deep in Greece? Were you elbow-deep in... Anyway, here's the Athens neutron monitor. And Athens is pretty flat over the past 30 days. Next, we'll go even farther south. How about Mexico City? Also pretty flat over the past 30 days there at Mexico City. Cosmic ray monitor. And next, we'll look at Oulu. Here's Oulu, also flat over the past 30 days. So some cosmic rays happening at Apatity for some reason, but not at the rest. So we'll just consider that anomalous data there. Here's DOMB Antarctica. Looking pretty cyclic over the past 30 days, but flat. Here's DOMB Antarctica, a similar graph to DOMC. We have seen an uptick here in the past day or two. So if you've noticed people being extra stupid, perhaps it's because of cosmic ray flux. And by the way, energy from different galaxies actually can affect things here. Believe it or not, it sounds crazy, but it could cloud up the planet for thousands of years, we think. So if that doesn't spark your interest in cosmic rays, I don't know what does. Which brings me to our mission. So let's take a brief moment to talk about our mission. You can read about it yourself at smashomash.com/forum/mission. But here it is. It's to assist, study, and report on the ongoing formation of a unified theory of physics. Why? Because there are some issues with physics. To raise the awareness of the general public of the relationship between Earth weather and space effects. I think I've just cited one of those. To connect and consult with media organizations to multiply our reach. To demonstrate cutting-edge proof-of-concept solutions to problems. More on that at a later time and in our playlists. To publish scientific papers in a multidisciplinary manner, including but not limited to the sciences that are scrolling up the screen. To assist mankind by advancing the study of predictive phenomenon. And not nonsense. In order to optimize value, reduce risk and liability, save lives and resources, and adapt, no matter what the adversity is. Even if it's energy from a distant galaxy or something spooky in our galaxy. And last but not least, to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion. Again, you can read more about that at smashomash.com. We're going to pick a random number today. The random number is 473. Here's a non-random object. It's Cygnus X3. So this is Cygnus X3 on the Chandra X-ray telescope. And this is a high-mass X-ray binary where a Wolf-Rayet star is being orbited by a more massive object with a periodicity of about 4.8 hours. So yes, this massive object, which some people believe is a, quote, quark star, is a local blazar, essentially. It's a high-mass X-ray binary with one of the poor little jet fields aimed directly at us, which is what you're looking at here, and why this is the brightest intrinsic object in the sky. It's known as Deneb, the tail of the swan, and you may want to read our Cosmology forum about it if you're not familiar. But let's just ignore all of that and go look at object number 473 instead. By the way, the graph for Cygnus X3 has recently been expanded. This is the X-ray flux from Cygnus X3. And you notice the graph is now showing all the way up to 0.2. See that? It goes all the way up to 0.2 now. Whereas over here, the historic graph, if you notice, only goes up to 0.1. Why is that? Because we saw some of the strongest X-ray outputs from Cygnus X3 that are so strong that they'd be off of the screen. So just putting that out there. You may want to know something about that. More about that in a moment. Let's go to object number 473. 473 is quasar QSO B1413 plus 135, a BL Lacertae object, a type of full spectrum active galactic nucleus. This quasar here is pretty consistent in its X-ray outputs, as you can see there. Let's take a look at it. It may look like a galaxy. It'll probably look more like a single point of light. And let's look at it on Aladdin light. And it does look largely like a galaxy. How about an infrared? We may get some extra features. Nope, it's looking pretty distant. So since this is classified as a QSO, it is indeed a quasar. So this is one of the ones where you're almost directly in the poloidal field, but not quite. Anyway, these BL Lacertae objects are full spectrum type. There is the X-ray flux from it. And let's talk about the forum once again. smAshomash.com/forum features a cosmology forum. So one of the sections in the cosmology forum that you're welcome to come check out, it's still free, is the cosmology forum. And we've got various threads there, going back to Cygnus X3, otherwise known as Deneb, the tail of the swan. Also, celestial pole star. Cygnus X3, otherwise known as Deneb, or Alpha Cygni, the brightest star in the constellation Cygni, or the brightest intrinsic object visible from our solar system. Yes, the brightest object in the galaxy is indeed Cygnus X3. And we've got a whole forum thread about this because, well, apparently the ancients found it to be important, and every time I inform people of this, I hear crickets. So I just figured I'd let you know, because I see so many people barking up so many of the wrong trees. I prefer to show them the correct trees and continue on with the implications of this information. So perhaps check out smAshomash.com/forum, the forum thread about Cygnus X3. Gobekli Tepe is oriented toward it, if you're wondering. And also all kinds of other objects. Again, this is the celestial pole star at the other end of the, quote, precessional, end quote, cycle. So all objects, when they rotate, folks, they wobble. Their axis wobbles. It's just a fact, because these objects aren't perfectly symmetrical. And they're going to wobble as they spin. And what happens is you have different celestial pole stars as a result of Earth's axial wobble. And at the other end of the precessional cycle, Deneb is the celestial pole star, this high-mass X-ray binary. If this Wolf-Rayet star were in our solar system, you would be inside of it. It's about the size of Mars's orbit, which makes it, I think, something like 1,700 times the size of the Sun. I don't know what the mass estimation is. I just won't even go there. But we do have a super interesting article about X3 in our forum. So if you've never read about X3, go have a read about X3. It's one of the only known cosmic ray point sources. As this high-mass X-ray binary is able to send particles directly through your head, and does regularly if you're in the northern hemisphere. So I didn't know if you were aware of that or not. I thought you might find it interesting that a star with an argued distance, we don't know if it's 3,000 or if it's about 18,000 light years away, but it's somewhere between 3 and 18,000 light years away. and its poloidal jet is providing cosmic rays. Now, this object was actually discovered while somebody was building a thing like a cosmic ray detector under 1,000 feet of granite in Minnesota. They detected the 4.8 hour periodicity of this and wondered what that was. They thought it was the Ruskies setting off nukes. Just kidding, folks. They didn't think it was the Ruskies setting off nukes. But anyway, they discovered that it was indeed this object. So, and here's a reference to the tail of the swan. That is actually the star that we're talking about. That is actually a depiction of it if you read about this. Yeah, it's, you may want to, it's, yeah. And don't tell me that it's just electric, because there are some actual science papers about this. It's not electric. There is a massive object orbiting a less massive object, apparently, and it's siphoning matter off of the other object. So there's an ionized gas disk in between the objects, and that is the actual source of the part of the emissions from this. So by all means, read the papers. We've got several different papers about this, as it's been fairly heavily studied. And it's actually in a very X-ray loud state right now. So if you've got access to a radio telescope, please tell your favorite radio astronomer to go have a look at Deneb. It's kind of important. So anyway, this is about the disputed distance. Here's a reference to Deneb's size with comparison to the sun, and we'll just move on and end today's cosmology segment as I'm losing my voice. And let's put your chats back up on the screen before we end the cosmology segment. And a user asks if I've seen the LASCO C3, to which I ask, have you seen the beginning of the video? Yeah, there's news on the CME. It's going to miss. We'll briefly touch on it at the end of the video as well. We'll go back and refresh since it's a YouTube live stream. Next, we're looking at the X-rays. I mean, not the X-rays, the electrons. Here's the electron situation. And we're going to see the electron flux crater here. And indeed, there it did. Cratered right after the coronal hole wind stream showed up, folks. And our regular viewers would probably have been able to forecast that. Not a big deal. But expect to see some anomalies here. You may see some GPS errors where you wouldn't otherwise expect them. And you may also see communications breakdowns happening here with the geomagnetic storm. So here's the electron flux over the past 3 days, and this is going to probably remain cratered here for a solid 36 hours, maybe even longer than that. But I would say the next day and a half, we'll see quite low levels of electron flux and electron anomalies. So there's the forecast. NOAA largely agrees with me there. And here is the visualization. And we'll probably see some anomalies happening already in the electron flux here. You can see nighttime blobs of electrons, mainly north of the equator, as the north moves into springtime and the south moves into fall. And by the way, that is showing you about 12,500 miles. In other words, the inner Van Allen belts are what you're really seeing on that. That is essentially the inner Van Allen belt from the perspective of a flat Earth. Next, looking at the ionosphere, just one slice instead of the entire air column. This is only about 300 kilometers of altitude. It's the Ionosphere Map. And don't worry about those red blobs, folks. Those are pretty irrelevant. Ionosphere not looking particularly oddly at the current moment. A couple brief charge ups and charge downs there. Here's the latest image. This one's from 9:45 Universal Time. We're around our normal time of being at this point of making the video. It's just live this time, which means I don't have to type. Because normally on YouTube, we watch the live premieres and because I'm the editor-in-chief, folks. So. And Mary reports that a 7.0 earthquake just happened off the coast of Honshu. Let's go back to earthquakes, and there it is. A 7.0 happening while we do the live stream. Take a look at the location of that. And thanks for the update, Mary. Just off of Ogatsu Bay. I don't think they cause tsunamis when they're that close to the land, do they? Let's check the Tsunami Warning Center. And there is a tsunami threat. Check it out, folks. We've got a lavender threat. Hazardous tsunamis are possible within 300 kilometers of the epicenter along the coasts of Japan. Check it out. They've got estimated arrival times. So that happening suddenly. And thanks again, Mary. Here's the second one. Pacific-wide tsunami not expected. And no tsunami threat to Hawaii. Here's the third one. West coast of the U.S., there's not going to be a threat for that. It's in pretty shallow water, folks. No danger for West Coast, British Columbia, or Alaska. Here's number 4, American Samoa International. No tsunami threat to American Samoa. And Guam. No tsunami threat for Guam, Rota, or Tinian, or Saipan. Cheers. Shout out to all our U.S. military personnel. Thanks for your service. Let's get back to the data that we were on. Where were we? I think we were on this. Anyway, the ionosphere map shows the F layer. So it's right around here, around 300 kilometers of altitude. And that is where the GOES 16 makes its measurements. That's why we show it daily, because we show so much data from that. And let's take a look at surface winds real quick. Here are surface winds of the eastern portion of planet Earth. And here are the jet streams. It's the 250 hectopascals winds. 250 hectopascal winds, folks. And here is the Western world in 250 hectopascal winds. We'll go back to surface winds momentarily. And we see a big kink in the surface winds here in the North Atlantic. Pretty weird. Pretty weird, folks. Some kind of a pressure gradient ridge there for sure. I'm sure it'll show up on the pressure map. Could be creating some rough seas there too. No major change in the wave propagation. A little bit of a low pressure system right here under my pointer. Anyway, let's move on. We don't want the video to be too long. It is indeed a daily space weather video. Here's where pressure cells are. And indeed, you can see this pressure ridge right here. No real surprise there if you understand the physics. Let's just advance this till tomorrow. This is the Euro forecast for pressure tomorrow at 2 p.m. 2 p.m. Sunday. There's where we expect pressure to be. Here's the GFS forecast. Again, there's the Euro forecast. And I do indeed see that almost all of Australia is in a low pressure zone. And check out the low pressures in North Africa as well. Very low pressure. Also extremely low pressure over most of southern Greenland. How do you like that? A 7.0 magnitude earthquake happening, as well as a coronal mass ejection, the Equinox, and a geomagnetic storm all at the same time. What are the possibilities of that? Apparently pretty high, because that's a thing. Anyway, here's blitzortung.org, and I would note the way the day-night lines are vertical. A feature only seen at the equinox. And if you're wondering where the sun's equator passed the Earth's equator, it must have been someplace around here. Wherever it was noon, wherever it was at solar noon at the time of the equinox was the specific location of the equinox, as there was a point in the Earth on the equator where the Earth's equator passed the sun's equator. Anyway, happy spring. Welcome to spring. Let us know in the comments what your exciting plans are. I'll make mine vague on purpose to support future content. I'm going to step on the gas. Anyway, we see a bunch of lightning here out in the Atlantic. Otherwise, pretty calm, according to blitzortung.org's real-time lightning map. You got to love a real-time lightning map, folks. It's good times. And you got to have control of your computer back if you want to be able to switch to the next tab. blitzortung.org. Don't make me come over there. All right. And let's continue on. Look at some meteorological phenomenon here over the U.S. Actually, let's go back to windy for a quick moment. I had a request to show Australia. Shout out to Jeff Brindley and to Kimberly and to, let's see, what is that? Bee Friendly Permaculture? I believe that is an Australian viewer as well. Let's show the weather radar. As I'm told, there's a deluge. Anyway, here's the weather radar animation. I think. Let's make that one step big. It's too big. All right, there we go. Here is the weather radar animation for Australia. Man, those systems are as stagnant as it gets. They're not moving at all. What is going on the satellite? Some great satellite imagery there, courtesy windy.com. Splentacular. Let's see if it animates. Just give it a moment, folks. Again, we are streaming live. And indeed, you've got stagnant pressure gradients. You've got stagnant pressure gradients. Nice. It is a strange place. It is a strange, strange place, folks. It is on the list of places I must visit at some point. So weird. All right, let's get back to U.S. weather here. Here's what's going on in the cloud layer over our heads. I would note all the low clouds. Are they caused by cosmic ray flux? Leave us a comment. Let us know what you think. Anyway, great view of that long line of clouds producing some lightning there. And here's the water vapor map. Again, there's the cloud layer. There's water vapor. And the eastern half of the U.S. is largely in dry air masses. Some low clouds over places like Louisiana, Mississippi, Alabama, and Georgia. Low clouds, folks. Do you know about low clouds? Have you watched our videos before, or is this your first time? Are you a total noob, or are you... Oh my God, what have I done? I've left the Smash News Network on the screen. And thanks for letting me know that there is no picture. All right. Did I not even show Australia? All right. I apologize. I even have a monitor. See that? I even have a monitor, folks. I screwed up. Oh my God. We're shutting down the channel, folks. Anyway, there's the cloud layer. Low clouds over Gulf of Mexico, Louisiana, Mississippi, Alabama, Georgia, southern South Carolina, and much of the Atlantic Ocean. You can see those low clouds, really obvious. Here is the water vapor map. Great overlay there showing you the difference between water vapor and clouds. It's still too dark to see them where I am. And if you're wondering where we're located, we're in Lehigh Valley, Pennsylvania, right about there. Here's a U.S. Doppler radar. A bunch of moisture there in the northwestern portion. And a little bit in places especially like southern Tennessee, south central Tennessee. Here's what we were seeing when we did show prep. And it's refreshed on me. You screwed me over. All right. Here's the current situation. Again, I would note this active region rising over here, the geomagnetic storm conditions. And we're going to go back and refresh Stereo A and the LASCO to show you the latest data on that before we close out. But you can see sunspot 2810. I think you can see sunspot 2810. There we go. Wonderful. Is only a alpha class sunspot. Move that down a little bit. It's an alpha class sunspot, folks. It only has one polarity umbra, and it's been shrinking steadily since yesterday. But we see once again another active region rising there. Is it a sunspot? Well, it doesn't appear to be yet, but if I had to guess, I'd say it is. You can see how you can see a bit of a divot already showing its way through there. And we've got some more animated imagery as well. Here's 94 angstroms. What the heck? Why is it running so slowly? That is koofed. Here's 335 angstroms. I think it needs a refresh. There we go. Just give it a minute. Again, we are streaming live here. We're trying to download the imagery as we speak. And that has taken all day. There are too many people visiting the SDO site right now. There we go. There's a good 335 angstroms. No, it's not. All right, let's go to 193, and then we'll go back to the Integrated Space Weather Analysis Center. We want to show you the coronal hole that's providing the coronal hole wind stream. It's this one right here. It couldn't be more obvious. And lots of stuff is obvious in cosmology. It's just a matter of looking at the right data, folks. Looking at the right data. And the coronal mass ejection propagated from this area, somewhere in here. in here, somewhere in here. And now we're going to go back to ISWA, and we're going to refresh these. So just give me a minute to pull these up to give you the most current data. So here's stereo A first. And we're going to go back 30 frames. And there you can see the propagation of that coronal mass ejection. It is not fully done releasing yet, as far as I can tell, folks. We can have these plumes extending out for several solar diameters. And the solar diameter is reflected in this white circle here. That's the actual, that's the chromosphere. That's the edge of the chromosphere, folks. The rest is corona. So, and we can have extended periods where plumes such as this remain there for a week at a time, even longer than that. So this is not done propagating yet. We'll probably make a second video later today to reevaluate this. But we're going to show you the same number of frames here. Hopefully it's the same dates. It might not be the exact same times, but we'll see if we get any additional data on LASCO C2 and C3. So here's C2. There could be an Earth-facing component with that. I do see some ejecta coming out way up here, as well as way down here. So there could be a bit of an Earth-facing component there. I see a little bit of ejecta on the west side as well, but keep in mind, folks, the Earth is moving in this direction. That's the direction that the Earth orbits the Sun in. Here's the LASCO C3. This may show us more. It may show us less. Pretty decent view there. I would still say this is most likely to miss to the east, but again, this may not be done ejecting yet. So we'll have to probably make a second video about this later today. And it's time to close this thing out, as this thing's been streaming for quite a while. We'll close out on the 193 angstroms view, since in fact, we'll even zoom in on the coronal hole, since it's what's providing the current geomagnetic storm conditions. There's 193 angstroms with that coronal hole and the coronal mass ejection propagation there, right on the end of the video. Thanks again for tuning in, folks. Remember, stare at the sun, don't drink, and if you do, don't drive. Thanks for leaving comments, everybody. Happy equinox, happy spring, happy fall if you're located in the southern hemisphere. I've been your host, Dan, a.k.a. smAsho. Don't forget to press like and subscribe if you enjoy the content. And we'll see you next time at the Daily Space Weather.